In Young's double slit experiment with monochromatic light, fringes are obtained on a screen placed at some distance from the slit. So d1 is the distance where that screen is kept. Now if screen is moved by 5 into 10 raised to minus 2 meter towards the slit, when screen is moved towards the slit, the new distance will become d2, and as a screen is moved towards the slit, it means d2 is less than d1, and here it was given screen is moved towards the slit by, means d1 minus of d2 is equal to 5 into 10 to the power minus 2 meter. 5 into 10 to the power minus 2 meter towards the slit. The change in fringe width, since x is equal to lambda capital D by D, x is directly proportional to D. As x is directly proportional to D, therefore change in fringe width x1 minus x2 is equal to 3 into 10 to the power minus 5 meter. If the separation between the slit is, separation between slit means small d is given 10 to the power minus 3 meter, then the wavelength of light used lambda we have to calculate. See here, x1 is equal to lambda d1 by d, x2 is equal to lambda d2 by d, and therefore x1 minus x2 is equal to x1 minus x2 is equal to lambda by d is common, and in bracket it is d1 minus d2. Therefore x1 minus x2 into small d divided by d1 minus d2, and that will give us wavelength lambda. What is x1 minus x2? It is 3 into 10 to the power minus 5. Small d, it is 10 to the power minus 3, and d1 minus d2, it is 5 into 10 to the power minus 2, and that is equal to wavelength lambda. That is equal to wavelength lambda. So if you simplify it, it is 0.6, and here 10 raised to minus 5, minus 3, minus 8, and when it moves up, it becomes plus 2. So it is 6000 angstrom. Wavelength of light used is 6000 angstrom. So out of 4 options, option C is the correct option for this question.